So dear students, this is a very short video on the evaluation metrics. Earlier when we actually did the linear regression, I spoke a little bit on the evaluation metrics, and I mentioned that I'm going to just share with all of you some few points. So we have actually with us the several types of evaluation metrics. So the first one, we have this MAE, which means the mean absolute error. And then we have the MSE, which is the mean squared error. And then we have the RMSE, which is the root mean square error. And also we have the coefficient of determination R squared. So which one of these metric is actually better? So of course, we have seen earlier the objective linear regression is to actually find the line that minimizes the prediction of error, right? We have actually seen this before. And we actually use these metrics to evaluate the score in terms of accuracy of the model. So these are the several types of metrics that are used to evaluate the performance of the model. So the first one, so this is important, especially on the root mean square and also the MSE and MAE. So make sure that you know each of these evaluation metrics and their formula and what do they actually represent. So let us look at the first one, which is on the mean absolute error. So from the name itself, we can actually make it up. So this is actually the absolute error. If you look at the equation, this is actually when 1 over n is actually a number of samples. So this is basically is taking the average, but it's taking the average of the absolute difference between the actual and predicted values. So you can see here there's a modulus, right? So and y actually refers to the actual value, and y, and with that this is called as a hat, it's overhead. So y hat is actually a predicted value. So the absolute difference, so that's why we have the modulus. So this is the average of the absolute difference between the actual and predicted value. So this is the mean absolute error. And then the next one is mean squared error. So it is almost the same, but it is actually taking the average of the squared difference. So here now you can see it is actually taking the squared difference. This is actually the distance value, right, between the original. So earlier when we actually using the mean absolute error, it actually measures the average of the residuals, the data set. And this one, it measures the variance of the residual, how much it actually varies. So this is the MSE. So you can see this formula. So this is all very important formula for you to know. Make sure you know the correct. If MSE, it actually takes the squared difference. MAE, it actually takes the absolute difference. And we have the root mean squared is nothing but the square root of mean square error. So variance square root, what you'll get the standard deviation of all the residuals. So this is the formula for that. And there is one thing that is known as the coefficient of determination, or known as the R squared. So this one represents the proportions of the variance in the dependent variable, which is explained by the linear regression model. So every linear regression model will have its R squared value. So this R squared value is actually a scale-free score. So it doesn't matter how big or small the value is, the value of R squared will always be less than 1. It always will be less than 1. So this R squared value, basically it actually shows how well those independent variables in the linear regression model and how much they are actually varied with respect to the dependent variables. So that is the R squared value. So the R squared value, the considerable value is should be closer to 1. That is the desired one. So we will see in terms of all these metrics, right? Mean squared error. So most of the time, RMSE is actually widely used respect to MSE. Now we have the MSE and also MAE, but most of the time either use the mean squared error, and specifically more than that, RMSE is actually used even more often. So RMSE is actually used as a default metrics for calculating the loss function. So this is you can see in most of the machine learning models, they actually use this RMSE value to evaluate. So how do we actually evaluate? For MAE, MSE and RMSE, higher accuracy means getting a lower value. So the lower value that you get for all these three, the better accuracy is a regression model. But for R squared, the higher value is considered desirable because the more higher the value is, it shows the variability of your independent variables with regards to the dependent variables. So yeah, this is what I was saying. R squared is used to explain how well the independent variables in the linear regression model explain the variability in the dependent variable. So the independent variable and the dependent variable. So dependent variable is the one, the target that we want to actually predict. And we want to see the independent variables in the linear regression and how much it actually affects the dependent variable. So for comparing the accuracy among various different linear regression models, definitely RMSE is a better choice. So RMSE, the root mean square, it actually gives a loss function. It gives an overall loss function. So which means it gives an overview of how well your regression model is performing. Okay, so these are some of the points. So take note that these points are very, very important.